Good day everyone, and welcome to the fourth video in a series of videos visualizing the characteristics of a tangent function. In the third video, we managed to create a spreadsheet, so this is it, here in GeoGebra to plot the tangent x function points for the first and second quadrant angle values, 0 to 180 degrees. Now we will try to extend our tangent function visualization by adding a slider from 361 to 1050 degrees to demonstrate how the tangent function continues beyond 360 degrees or beyond one revolution. And we're also going to explore and plot points for negative angles to illustrate the tangent curves on the left side of the y-axis. This is the y-axis. We have tangent curves at the left, right? So these are for the negative angle values. We will then describe the periodicity and curves of the tangent function. Alright, so let's see how far we can go for this fourth video. So please join me until the end of this video series. So let's begin. So we are now going to add the tangent function points for the angle values in the third quadrant and in the fourth quadrant. So from 180.001 to 360 degrees. And we're going to have violet points for the third quadrant points and orange points for the fourth quadrant points. Let's observe, so we're just going to add angle values more than 180 degrees. Like that, and up to 360 degrees. For columns B and C, we just need to drag down because we already have a predefined formula for it. Of course, don't forget the color coding. So for the third quadrant, we're going to have violet. For the fourth quadrant, that's beyond 270, we're going to have orange. And now we're going to add a slider from 0 degrees to 360 degrees in order to illustrate and visualize the movement of the data points of the tangent function from the first quadrant points to the fourth quadrant points. This would be beautiful, so please observe. Color this point black or gray. It's from 0 degrees, it moves up. So that would be the first quadrant points, and then second quadrant points, third quadrant points, and fourth quadrant points. Alright, so let's extend our tangent function visualization. We're going to add a slider from 361 degrees to 1050 degrees or 1050 degrees to illustrate multiple circular revolutions. And we're going to demonstrate how the tangent function continues beyond 360 degrees. So please observe. And let's color this one yellow. Or neon green. Ready to slide the slider with me? Alright, so look at the movement of C41 along the tangent curves of the tangent function. Alright, so let's explore further. And now we're going to have negative angles as our input. So we are going to add a slider from -10 to -1020 or -1020 degrees. So we're going to illustrate the tangent curves on the left side of the y-axis and to highlight the scope of the tangent function's domain, emphasizing negative angles. Okay, let's have pink points. Are you ready to slide the slider with me? So let's do so. Alright, so the tangent function graph continues beyond at the left side of the y-axis. Alright, and now let's make it more exciting by adding a unit circle and creating angles for each slider. So please observe. Angle AC2C is now ready, so let's slide the slider alpha. So in the first quadrant, and then second quadrant, third quadrant, and then fourth quadrant. Same angle AC2C, but now we're going to slide the slider beta. Are you ready? Okay, let's observe. This is the visualization beyond one revolution. So beyond one revolution, another revolution, another revolution. So again, observe the period. Okay, so one period meaning one semicircle. So that is one period. And then this one is another period. Then this is another period. This one is another period. One period of a tangent function will comprise one upper part and one lower part. And that would mean one semicircle. Look at that. So this is half of the semicircle and this one semicircle, so that's one period. Half of the semicircle, that's the upper part, and the other half of the lower part. And the whole semicircle is one period. For the negative angles, so one semicircle is one period, half of a semicircle is half a period, and the whole semicircle is one period. So one semicircle, one period, another semicircle is another period. Alright, so let's have a recap. So again, one semicircle covers one period, forming one tangent curve. The third quadrant values represent the upper part of another tangent curve. In the third quadrant, both x and y coordinates are negative. And since the tangent function is a ratio y over x, then the tangent value in the third quadrant is positive. Right? Because negative y divided by negative x is a positive number. In the fourth quadrant, values represent the lower part of another tangent curve, and it completes the second period of the tangent function. The infinite tangent curves along the x-axis illustrates that the angles extending beyond one revolution of a circle. So these infinite curves at the right and at the left signify the domain. Okay, and that it says that the domain covers all real numbers except where k pi plus pi over 2 indicated by the asymptotes. So these numbers, okay, that satisfy this equation is not included in the domain and will be indicated by the asymptotes. So again, the domain of the tangent function does not cover all real numbers because there's an exemption, and this is the exemption. So we have multiples of pi plus pi over 2. We're going to illustrate that now. So multiples of pi, so let's have a slider k. So let's have negative 100 to 100. So let's change this to k, slider k, and then that would be x is equal to k pi plus pi over 2. Ladies and gentlemen, enjoy, okay, as we visualize all the asymptotes, the movement of the asymptotes. So each period we're going to have an asymptote. Here are now the asymptotes. Okay, did you see that? Alright, so the formula again is k pi plus pi over 2. Multiples of pi plus pi over 2. Because one period for a tangent function is pi over 2. So in every period there would be an asymptote, right?